Greetings. Today we are going to present our group assignment for the course Multivariable Calculus BE 20303. We are from section 5, group 5. Our lecturer's name is Dr. E.C. Key. I would like to introduce our group members. Sharlini Anna Perempuan Singadurai, matrix number CE 2000.64. Pavitra Anna Perempuan Yortharan, matrix number DE 200027. Madan Raj Naidu Anna Lalaki Sri Murali, matrix number DE 200017. Danish Anna Lalaki Sadasivam, matrix number DE 200010.
Greetings to lecturer. My name is Sharlini Singadure and my metric number is CE200164. I'm from section 5 and group 5. I'll be the first presenter to present question 1. So the question 1A1 is compute the multiple integral, and this is my manual calculation. The answer we obtained from the manual calculation is 203 over 120, and this is the last answer I going to prove in MATLAB programming. So this is the program for question 1A1. Now I gonna run the programming, and here you go. The answer is 1.6917, which is similar to 203 over 120. So my manual calculation last answer is proven with our MATLAB programming. So for question 1A2, this is the question 1A2, and this is my manual calculation. I get 76 over 3 as my last answer. So now I'm going to prove this in MATLAB programming, and this is the programming for question 1A2. Let's run. So the answer is 25.3333, which is similar to 76 over 3. We can check the last answer in our calculator. So next, B. Question 1B is evaluate the following triple integral by using spherical coordinates. And this is my manual calculation for question 1B. The last answer I get is 6396.102. Now we check the last answer in MATLAB programming, and this is the MATLAB programming. We run the program now, and here you go. The last answer for the program is same with the last answer of my manual calculation. So the answer is proven. Next, question 1C1. By using the polar coordinate, evaluate integral rx square plus y square dA if R is the region in between circle x square plus y square equals to 1 and x square plus y square equals to 4 in the first octant. And this is the manual calculation for the question C1C1. And the last answer I got is 5.8904. And now we prove this in MATLAB programming, and this is the programming for question 1C1. I run the program now. The last answer I got is 5.8905. We can see that 1 point is different. Here is 0.5 and here is 0.4, but seems it is similar, so the answer is proven. And then the last one is C2. By using double integrals, find the area of the region enclosed by y equals to sin x, y equals to cos x, x equals to pi over 4, and x equals to pi over 2. So this is my manual calculation for question 1C2. The last answer I got is negative 1 plus square root 2, which is I can prove in MATLAB programming. This is the program for question 1C2. We run the program now. So here the answer 0.4142. 0.4142 is equals to negative 1 plus square root 2. We can check the answer in calculator. So the answer for question 1C2 also proven. All the questions for question 1 is proven in MATLAB programming. And that's all from me. Thank you.
Hi, I'm Pavitra Yultharan. I will be in charge of question 2 multivariable calculus project. As we can see, this is my question. So for part A, find the first partial derivative of Roman 1 f bracket x comma y comma z equals to x square y over z cube. By doing the working, the final answer for this manual calculation is negative 3x square y over z power 4. This is the simulation for the question. So after running, this is the output for that question. As we can see, the answer for this output is negative 3x power 2 y over z power 4, which is similar to the manual calculation. And following the next part, which is Roman 2 for question 2a, f bracket x y z close bracket equals to exponent y z cos x y. By doing the working, the final answer by finding the first part derivative, which is equals to y exponent y z cos x y. So this is the simulation for question 2a Roman 2. When I run this simulation, as we can see, this is the output for the question, where the final answer is y exponent y z cos x y, which is similar to the manual calculation answer. For the next question, question 2b, solve dz over du and dz over dv by applying chain rule if z equals to ln bracket x square minus 2y close bracket and x equals to u plus v, where y equals to exponent v. By doing the following calculation, where we apply chain rule method, the final answer is dz over dv equals to 2x minus 2y over x v minus 2y. So this is the simulation for the question B. When I run the simulation, where this is the output for the simulation, as we can see, the final answer for this simulation is negative 2u plus 2v minus 2 exponent bracket v over 2 exponent bracket v minus bracket u plus v power of 2. For the next question, question 2c, show that the function z equals to exponent x sine y plus e y bracket 0 equals to x. Satisfy Laplace equation where d square z over dx square plus d square z over dy square equals to 0. So by doing the manual calculation, when we add the both d square z over dx square plus d square z over dy square, the final answer is 0, where it is proven in the question. So this is the simulation for question 2C. By running the simulation, we can see this is the output of the simulation where the final answer is 0, like how it is proven here. For question 2D, it has two Roman. So for the following equation, find the dz over dx if z equals to f bracket xy is Roman 1 y exponent xz minus 3y exponent yz, which is equals to negative 4z exponent xy plus 1. So by doing the manual calculation, the final answer for dz over dx equals to negative yz bracket exponent xz plus 4 exponent xy over bracket xy exponent z xz minus 3y square exponent yz plus 4 exponent xy. So this is the simulation for question 2D Roman 1. When I run this simulation, this will be the output of the simulation where it is negative yz bracket 4 exponent bracket xy plus exponent bracket xz over 4 exponent xy minus 3y power of 2 exponent bracket yz plus y xy exponent bracket xz. So this final answer from the simulation and the manual calculation answer is same. Moving to the Roman 2 question 2D, which is 2x square z power 4 minus 5 ln bracket xyz square equals to 4z. By doing the manual calculation, the final answer for dz over dx equals to 5z minus 4x square z power 5 over 8x power 3 z power 4 minus 4x z minus 10x. So by doing the simulation for question 2D Roman 2, when I run, this will be the output for the simulation where the answer is x bracket 4 x power 2 z power 4 minus 5 over x power bracket negative 8x power 2 z power 4 plus 4z plus 10, where this final answer and the manual calculation answer is same.
Hi doctor, my name is Madan Raj from Group 5, Section 5, and my metric number is DE200017. I will be explaining about the software solution for question 3. And the software that I used is MathCAD Prime. For question 3a, we need to find the divergence of the given vector. So let's look at the software solution. Okay. This is the software solution for question 3a, and firstly we need to find the curl of vector, and this is the formula for the curl of vector, and this is the final answer for curl of vector. So from this equation we need to find the divergence, and the equation was broken down into three different parts, and this is the combination of the three different parts. Okay. From that we can find out the divergence of vector, which is 0. The final output of this question is similar to the manually calculated answer. Okay. For question 3b, we need to find the work done by force field and judge whether the force is conservative or not. Okay, this is the software simulation for question 3b. Okay, the particle moves from point 0, 0 to negative pi 0, and this is the final answer for work done, which is pi cube over 4, which is similar to the manually calculated answer. Okay, for to finding whether the force is conservative or not, we need to do curl of vector, and this is the final output, which is 0. This means the force is conservative. For question 3c, we need to evaluate this given equation. This is the software simulation for this equation. As you can see, the final answer is 32805 times by 2 square root 2 pi divided by 8. This answer is also similar to manually calculated answer.
Greetings, I'm Danesh Sadasivam from Group 5, matrix number DE200010. Today I'm going to present the software simulation for question number 4. So firstly, I would like to explain about question 4b Romans 1. So we need to sketch the graph of surfaces. So first we enter the equations. X square plus y square equals to 4, followed by z equals to 4, and then plane z equals to 0, followed by cone z equals to square root x square plus y square. So this is the sketch of graph, also same as our manual solution. Question 4b2. In question 4b2, they have asked us to find the divergence of field XYZ. So this is the code for finding the divergence. SYMS XYZ field equals to y x times with y z was equals to XYZ divergence field times with was. So let's run it. So the answer will be x plus 1, which is also same with our manual solution. Next will be question 4b3. In this question, we must use Gauss theorem to evaluate the flux of the vector field across the surfaces. So in this coding, we have used fun function along with the equation, double integral, and also again fun function and the equation, z mean, triple integral, fun function, and the formula, theta minimum, theta maximum, r minimum, r maximum, z minimum, z maximum, and triple integral, and then fun function again, and the answer will be triple integration. So let's simulate. So the answer will be 33.5103, which will be also same as our manual solution, which is 32 pi over 3. If we convert this into a number form, the answer will be same. The following will be question 4C. In this question, we have to sketch the surface of the plane where the surface of the plane x plus y plus z is equals to 1. In the first octane contained with triangle C with the vertices 1, 0, 0, 0, 1, 0 and 0, 0, 1 transverse in anti-clockwise direction. So the code will be word equals to 0, 1, 0, 1, 0, 0, 0, 0, 1. Patch vertices word faces 1 per 3. The face color will be the color of the output, blue. View, we are using two types of set, which is x direction reverse, y direction reverse. Grid on alpha 0 multiply with 5. So let's run. So this will be our output. Question C2. In this question we must evaluate the vector field using Stokes theorem. So to use Stokes theorem, we have to define the fun function equals to xy 1 minus x, y max equals to xy 1 minus x, answer equals to double integral of fun function 0, 1, 0 and y max. So let's simulate. So the answer will be 0.333, which is equals to 1 over 3. That's all from us. Thank you.